Hi guys, welcome back to my channel, and today my topic is all about glaciers. Have you ever noticed glaciers in your life? We normally don't see them because they're out in the North Pole or South Pole. The smallest glaciers can be the size of football fields. The largest glaciers are continental sizes. But if they're not glaciers, this means that these are icebergs. Icebergs are typically smaller than glaciers. It depends on where you are and how the glacier moves. The structure of a glacier is simple. The top of a glacier is called the cirque. The bottom of a glacier is called the terminus. In this picture, you can see there's this little round semicircle. This is the start of a glacier. And as you can see, there's two glaciers, and at the bottom of each glacier, there's this cut, and it's called the terminus. At the terminus, there's usually lots of ice chunks, like in this picture. When these ice chunks separate, this is how you know it's the terminus. It has lots of ice separating in a puddle of water because snow is melting and falling off of the glacier. When two glaciers merge, they become another glacier. You can tell there are originally two glaciers because there's two cirques. They emerged because rock particles connected together, and over time, the snow will cover it up, so it looked like those two glaciers never combined. In glaciers, if you notice really closely at glaciers, which I don't live near glaciers, so I don't see these glaciers really often. But if you look very closely to glaciers, you can usually see small streams where water flows in through the glacier. There's typically boulders that will block the streams because those boulders will come from rock falls that roll off the glacier. The glacier acts like a time capsule because it stores information. For example, there was this person petrified and preserved in snow. So that's how scientists discovered how humans were like back then. You can see this pretty landscape in this background. There's blue ice ceilings and walls. There's gigantic air bubbles. This is inside the Muir Glacier in Alaska. As you can see, this was made from sinkholes, and sinkholes are when the surface clots and there's no more surface, so that's why it forms a big hole on the ground. The Muir Glacier is special because, as you can see, there's lots of blue light reflecting it. Glacier ice can vary on sizes and density. The more denser it is, the more deep located is it underground than lighter glaciers. This is an example of blue ice. Blue ice was technically just snow, but over time and hundreds of years, it became very dense with almost no air. First of all, airborne snow is when air is surrounding the snow and the snow is in the air. So like in this picture, there's snow that's in the air. This has over 100% of air. But then as we get down, snow is what we call the white stuff building up on the ground. Snow is usually up to 85% of air, and that's still a lot. But as we get closer to the core of the earth, we have granular ice. Granular ice is ice that's ranging from 30 to 75% of air. And firn ice is one step above blue ice, and firm ice is 20 to 30% air bubbles. Then at last, blue ice, which can only reflect the bluest rays of light, is the last type. And blue ice is any snow that's counted 20%, only 20% of air bubbles. You can imagine that. I don't think I ever seen blue ice before that, but that sounds pretty cool because I think its name came from what color it is. Then finally we have the movement. Movements of glaciers are simple. They can be caused by temperature because if it's windy, it probably can move the glacier. But most glaciers will stand on the ocean, so that's why oceans can move the current and move the glacier as well. This is an example of a river freezing, and when at the end of this river, there's ice chunks floating off. This is because there's not enough snow or snowfall to get down there, so that's why it starts to melt. And when there's not a structure or good balance of the glacier, it starts to deform. For example, if snow only fell on the top half of the glacier and not the bottom half, this would be a coincidence. And also, it's going to be very bad for the glacier. So if all the snowfall fell here and then not on the bottom, eventually the glacier is going to get smaller because there's no snowfall that's going to build up after the snow melts on that layer. That's partly why glaciers shrink, but glaciers can also grow when there's too much snowfall. Advancing and retreating glaciers is when glaciers will move forward or move back. Advancing is a term in Germany, and advancing means to move forward. Retreat is to move backwards. This is an example of a really retreating glacier, and this picture was taken in the 1900s, but now this picture was taken in 2002. Look what the difference is. In this picture, you can see more sky than in this picture. So that's why this sign shows that this glacier has been retreating a lot. An advancing glacier is also one in Alaska. This glacier was starting to move in 1989, and now recent photos show that it has moved a lot. This glacier has moved a 100-year-old forest with it. And as you can see, there's lots of tree damaging because the glacier is pushing the trees back and shoving them all into one place. Unfortunately, nowadays there are more retreating glaciers than advancing glaciers. Scientists believe this is because that the glaciers are starting to melt. So that's why people believe that it's because of global warming. Thank you for listening. Glaciers are a mysterious sight and wonder because we don't know a lot. But I love how these are referred to as time capsules because these keep information like what types of rocks were used in 1 century. Thank you for listening, and I hope you like and subscribe to my